All right, section 3-3, one of the most important and interesting sections in this book. I'll try to do a decent job on this. Phase changes of a pure substance. And in particular, we're really going to be looking at the boiling or the vaporization of a pure substance from a liquid to a vapor, right? From liquid to a steam. All right, so let's think about what this would look like on a temperature versus volume plot. All right, think about boiling water that is enclosed in a vessel. All right, maybe this vessel has a top that can go up and down, so the volume can change. All right, the volume can change, but nothing is escaping. There's no vapor escaping this tank. All right, as we are boiling it, as we are heating it. All right, so if we've got water, maybe we start right here at state 1. It's just a liquid, and maybe we have a top that keeps it a constant pressure. So this will be a constant pressure phase change of a pure substance from a liquid to a gas. And what if we put some heat to it? What if we put some fire to it, right? What will happen? Think about boiling water. What if you put some heat to boiling water? The temperature will rise, and the volume is not going to change very much as it is still a liquid. So maybe it goes from here to here, from 1 to 2 right there. A rise in temperature and not much of a change in volume. But then it gets to its boiling point, right? Water boils at 100 degrees Celsius. It gets to 100 degrees Celsius. What happens? Do you know what happens when you put more and more heat to that? It starts vaporizing, right? It starts boiling. But the temperature, y'all learned this in high school, right? The temperature stays the same. The temperature stays the same. And so then we would go on this horizontal line, and we'd get some liquid, some vapor, and the volume would start to increase, but not much of a temperature change. And so then maybe we're at state 3, where there's a mixture. Some of the liquid is vaporizing. Little by little, or fast, liquid is starting to vaporize. And so maybe we've got half liquid, half vapor, a quarter liquid, 3/4 vapor. It is beginning to vaporize, and the volume is increasing by a good bit. All right, then it gets to a point where all of the liquid has vaporized. It gets to a point, we'll call it state 4, where all of the liquid has vaporized. And then what happens if you add even more heat to it? Then the temperature will start to increase as it is all vapor. Now it is increasing. Its temperature is increasing. Its volume is increasing. This is what a constant pressure phase change might look like. All right, and so it might go from state 1 to state 2 to state 3 to state 4 to state 5. So let's look at each of these. These are kind of interesting points on the phase change graph. All right, state 1 is a compressed liquid. All right, it is 100% liquid. All right, it's also known as a subcooled liquid. Right? Most all liquid water that when we think of water, it's a compressed liquid. All right? But then it gets to point 2, which is the point at which it just begins to vaporize. All right? And so we're calling it a saturated liquid. That is saturated liquid. It is still 100% liquid. Right? It is still 100% liquid, but it is just beginning to vaporize. It is about to vaporize. Any infinitesimally small increase in heat, and it would start to vaporize. But at a saturated liquid, it is still 100% liquid, but that's the last point that it's 100% liquid. Anything above that, and it is going to be a mixture. So it is 100% liquid. It's about to vaporize, and it is at the saturation temperature. We think of it as the boiling point or the boiling temperature, but this saturation temperature is the temperature at the phase change. Saturation temperature is the temperature of the phase change. Okay. All right, then at state 3, it's a saturated liquid, saturated vapor mixture. All right, so it's not like all of this liquid, all of it changes slowly to vapor. It's a portion of the liquid goes straight to vapor. Another portion of the liquid, another particle goes straight. All of these particles are going straight from liquid to vapor. So it's a mixture, right? It's a mixture. A little bit of it has changed. A little bit more of it has changed. A little bit more of it has changed. A little bit more of it has changed. And so it's a saturated liquid vapor mixture. It is saturated liquid and saturated vapor. Both of them are at the saturation temperature. Saturated liquid and saturated vapor both are at the saturated temperature. All right, and then when it gets to 0.4, which is still at saturation temperature, but it has all 100% converted to gas. It is at the saturation temperature. It is on the verge of going back of condensation. Any decrease in heat, if you let off any on that heat, it's going back to starting to mixture, back to a mixture. All right, and then if you add even more heat, and we get out here anywhere past 0.4, then it's a superheated vapor. It is 100% gas, 100% vapor. And now the temperature has risen. It is above the saturation temperature. It is above the saturation temperature. Okay, that was one example. This is at one pressure, maybe atmospheric pressure right here. At a different pressure, it would have a different line. Maybe it's right here. At a different pressure, it'll have a different constant pressure line. All right, so that's a good page, but let's go to our handout right here. Yes, and so I took the figure in the book and tried to edit it to visualize it. And so this is what we were doing. This is what we were doing. We start right here. We add some heat. It gets to the saturation temperature, and then it starts. Some of it, a little bit of liquid changes to vapor. A little bit liquid changes to vapor. A little bit liquid changes to vapor. From 2, 3, 4, and then we have a superheated vapor anywhere above 4. Okay, so this is a constant pressure phase change right here, a TV diagram of water at constant pressure. Now, at different pressures, then we have different lines. So this is at 1 MPa. This would be at 8 MPa. This would be at 15 MPa. So different pressures have different saturation temperatures. This pressure right here would have that saturation temperature. This pressure right here would have that saturation temperature. This pressure would have that saturation temperature. This pressure would have that saturation temperature. Did you know that if you're boiling at a very high elevation, right above sea level, where the pressure is different, right, where the pressure is lower, your water will boil at a different temperature. Let's go back to our notes. Did you know that boiling point is dependent on pressure? And we're saying boiling point because I think of boiling of water, but also we're talking about saturation temperature is dependent on pressure. We just showed that with all those different pressures with different lines. At about atmospheric pressure, water boils at 100 degrees Celsius. But if the pressure was higher, it would take 151.8 degrees Celsius to boil water. If the pressure is lower, water boils at 93.3 degrees Celsius. Saturation temperature is dependent on pressure, but for a given pressure, there is only one saturation temperature. All right, for that material, for that pure substance. All right, so water at this pressure, it will boil at 100 degrees C. All right, for water. Water at this pressure boils right here. It's a 1-to-1. For a given pressure, there's one saturation temperature. For a given temperature, there's one saturation pressure. There's one pressure that this phase change happens. And it's maybe this line right here. For this temperature, that's the pressure. For this temperature, that's pressure. It's not like there's two different temperatures and pressures. Okay? So because there's kind of this 1-to-1 thing, then if I am at point 2, if I'm a saturated liquid, or if I'm a mixture, a saturated liquid vapor mixture, or if I'm a saturated vapor, anywhere on 2, 3, 4, then they are at the saturation temperature and pressure, so I know these are at saturation, the saturation point. So here we go. If you are given the temperature, and I'm at point 2, 3, or 4, if you are given the temperature, then I know the pressure. I don't need any other information. If I know it's water and I know the temperature, and I know it is either a saturated liquid, a saturated vapor, or a saturated liquid vapor mixture, then from the property table, I can get the pressure. From property tables, I can get the pressure. Same thing, if we are given the pressure, and I know it's at state 2, 3, or 4, then we can get the temperature from property tables. These are the property tables that are in the back of the book. We'll talk about these. These are property tables that you will have printed out already when you get into the test. But state 1 or 5, then no. If you tell me the temperature, I'm going to need some more information. All right. Whereas if I'm at state 2, 3, or 4, you tell me the temperature, and then I know I can look. Okay, what is the saturation pressure for that temperature? Or you give me the pressure, I say, okay, what is the saturation pressure for that temperature? Or if I may have said that backwards. Okay. All right, we'll talk about the property tables in just a minute. One more page of just kind of some definitions. Latent heat is the amount of energy during a phase change. All right, the amount of energy required for a phase change, or the amount of energy released during a phase change, whether it is vaporizing or fusion or condensing. All right, so the latent heat of vaporization is the amount of energy or the amount of heat to change from liquid to gas or gas to liquid, to change completely from liquid to gas or gas to liquid. That's the latent heat of vaporization. The latent heat of fusion is the amount of energy changing from solids to liquids. Solids to liquids. All right, for a substance that contracts on freezing, this is kind of its phase diagram. So for probably atmospheric pressure, most substances right, at a low temperature will be solids, and then here they'll be liquids, and then they will be gases. At very low pressures, though, sometimes things can, and it depends on the substance, at what pressures these happen, but sometimes things can go straight from solids to gases, right, straight from solids to gases. For substances that expand on freezing, their phase diagrams look a little bit more like this, where we've got this right here, where that melting line goes in this direction to the left. So larger pressures, you actually have a smaller, a less temperature needed to change from solids to liquids, right there. All right, water's phase diagram looks like that, right there. Okay, let's talk about these property tables, because we haven't used them yet. This is our first look at our property tables. So let's get comfortable with them. Here are our property tables. Appendix 1 and Appendix 2 in the back of our book. Appendix 1 is SI units. Appendix 2 is English units. All right, so Appendix 1 is SI units. It's a lot of pages, right? 40, 50 pages. Appendix 2, it has an E on all of these. They're the English units. And you can look at the units. You'll see lots of English units, SI units on Appendix 1. So here's a kind of an overview of the property tables that we need to be looking at right now. All right, let's look at 4, 5, 6, 7, and 11, 12, 13. All right, 4, 5, 6, 7, and 11, 12, 13. So let's forget about everything else. Don't get bogged down in 1, 2, 3, and 8, 9, 10, and all the higher ones, because we're looking at pure substances. All right, so do you see that 4, 5, and 6 are for water? 4, 5, and 6 are for water, whereas 11, 12, 13 are for refrigerant. All right, refrigerant, a different pure substance. Refrigerant 134A. All right. So Appendix 1 is SI units. Appendix 2 is English units. So that's kind of the first thing. Is my problem in SI units or is my problem in English units? Okay. Then the next thing is, am I talking about water? Am I talking about refrigerant? If I'm talking about water, then I'm looking at tables 4, 5, 6, 7. If I'm talking about refrigerant, I'm looking at tables 11, 12, 13. Okay. 4 and 5 are saturated tables. Okay. 4 and 5 are saturated tables. Or 11 and 12 are these saturated tables. 11 and 12 are these saturated tables. 6 is superheated, 7 is a compressed liquid, right? 6 is superheated, 7 is a compressed liquid. So if we're kind of going back to this right here, this 1, 2, 3, 4, 5, 2, 3, and 4, I would be at the saturation temperature. 2, 3, and 4, I would be looking at the saturated tables. Tables 4 and 5 or 11 and 12. Okay? Whereas if I'm superheated, I would look at the superheated table. If I'm compressed liquid, I would look at the compressed liquid tables. Okay, so let's start with points 2 and 4. A saturated liquid and a saturated vapor. To find the properties of a saturated liquid or a saturated vapor, I would go to the saturation tables 4 and 5 or 11 and 12. The saturated liquid properties have a subscript F. So H, F, U subscript F, V subscript F, S subscript F. All right. H is enthalpy, U is internal energy, volume, and entropy. So anyway, the saturated liquid properties have subscript F. So let's go to tables 4 and 5. I went way too far here. Let's go to tables All right, 3 is, we're not worried about. We need to get to, that's table A2, table A3, table A3. Here, table A4. All right, so here, VF, UF, HF, SF, that is the saturated, if it is, and it tells you right here, if it is a saturated liquid. So maybe I know it's a saturated liquid at that temperature. There's its specific volume. Here's its internal energy. Here's its enthalpy. Here's its entropy. So the subscript F are the saturated liquid properties. All right. Table A4 is for water. It is saturated, and it is organized by temperature. Okay. Whereas table A5 is organized by pressure. So if we know it is saturated liquid and we are given the pressure, then we would come to the pressure table, and any of these subscript F are the saturated liquid properties. All right, saturated. That's going to be the easiest one. Saturated liquid properties are these on the subscript F column right here. Well, what do you think saturated vapor properties are? They're these right here, right? Subscript G. Subscript G. So let's go back to our notes. This would be H, G, U, subscript G, V, G, S, G. Those are the easiest. That's what we're going to start with. Finding the properties if it's a saturated liquid or if it's a saturated vapor. So H is enthalpy. We haven't talked about enthalpy. Enthalpy, briefly here, combines internal energy and flow work. All right, so enthalpy combines internal energy and flow work, whereas internal energy is just U. These are all lowercase, and you could look at the units on the property tables, and that would show us and tell us that we're looking at specific properties. All right, so saturated liquids, we look for the subscript F. Saturated vapors, we look for the subscript G. Here let's give an example. All right, so we're going to do lots of examples real quickly. But let's say I have a saturated liquid. It is water, and we're in SI units. And I'm given the temperature. Here's the order that I look at. All right. First, I think SI or English units. All right. So first, SI or English units, because SI is Appendix 1, English is Appendix 2. So SI, so start here. We're in SI units. Then I say water or refrigerant. Okay. Because water, our tables 4, 5, 6, 7. Refrigerant, tables 11, 12, 13. All right, this is water. So I know I'm in 4, 5, 6, 7. And then if it's saturated or not, so if it is saturated, then I'm in tables 4 or 5. All right, and then I am given temperature. That would be the temperature table. Table A4. So for this one, I would be looking at table A4, and I would look for that temperature that I'm given, and I would look for subscript F because it is saturated liquid. Okay, so first, SI or English units. Second, is it water or refrigerant? Third, is it saturated? Either saturated liquid, saturated vapor, or saturated liquid vapor mixture. So then I would go to tables 4 or 5. If it is superheated, I go to table A6. If it is compressed liquid, I go to table A7. All right, but this one was table A4. All right, how about this next one? Let's try this next one on your own. Maybe pause it for a second and say, okay, if I have a problem where I'm given SI units of water and it's a saturated liquid, but I'm given pressure, what do I look at? So if it's SI units, I know I'm in Appendix 1. If it's water, I know I'm tables 4, 5, 6, 7. If it is saturated, I know I'm tables 4 or 5. All right. which one, 4 or 5. I'm given pressure. I need to go to the pressure table, table A5. And I would take that pressure and look for the subscript F for saturated liquid. We'll do a lot of these problems, but I want us to just kind of, this is our process. First, SI or English units, then water or refrigerant, then saturated or not, and then pressure or temperature. All right, how about this next one? We're in SI units, so appendix 1, not the appendix with all those E's on the end of it, not appendix 2. Refrigerant, okay, refrigerant. So I'm looking at tables either 11, 12, 13, right? 11, 12, or 13. Saturated, so I'm looking at tables 11 or 12. And then I'm given P, so I'm looking at table 12, table A12, and it's a vapor, so I'm going to look for subscript G at that pressure. At that pressure. All right, one last one. Then we'll do some problems. One last one. Okay, I'm in English units, so I'm in appendix 2. You know, appendix with all those E's on the end. I'm in appendix 2. Refrigerant, so I'm looking at 11, 12, or 13E. All right, 11E, 12E, 13E. It is saturated, so I'm looking at 11 or 12E. All right, and we're given the temperature, so I'm looking at the temperature, table A11E. Table A11E. I'm looking for saturated vapor, so I'm going to look for subscript G. Subscript G at that temperature. Look for subscript G at that temperature. All right, so you see the way that I do this, my process, is look at the units. You know, are we kilojoules, kPa, meters? You know, are we in SI units? Or do you see some pounds, some BTUs, some pound mass, feet, inches, you know? So look for SI or English, then water or refrigerant, and then is it saturated or not? And then are we going to the saturated pressure table or the saturated temperature table? Okay, now let's do some problems. Let's do some problems.